folks, welcome to the Architecting GenServers for Testability talk. My name is Tyler. Very briefly about me, I'm a team lead at a company called Imbala. We make a software as a service platform for energy utilities to help them balance energy production against demands. I like to joke that I'm a recovering C++ developer. I spent 10 years at a flight simulator company called X-Plane. And toward the end of my time there, I got to make this massive multiplayer server, game server, and used Elixir for it. And so when I was ready to move on from the world of flight sim, I was specifically looking for stuff that I could do Elixir full time. So as a caveat, I really like this quote. I'm not an expert. I'm just a dude in kind of testing this presentation out on some people. Some of it is going to be controversial. You probably won't agree with everything, and that's cool. You might be right, or maybe we might just be coming from different places and different experiences. So I figure in the worst case, this is maybe a good place to start a conversation with your team or other people you respect. So I've structured this talk as what I'm calling an exercise in comparative architecture. So we're going to start with a version of a code base that is pretty bad. It is probably not the worst code you've ever seen, although maybe you're lucky, and it is. And then we're just going to apply a series of refactorings over it to improve the architecture, improve the testing story, and kind of tackle some things that bite us in the real world. We're going to be focusing on three areas in our refactorings. The first is this separation of concerns. We're going to be trying to keep things that are conceptually distinct in our code base, and the opposite side of that coin is that we're going to try to keep things that are conceptually closely related close together in the code. If you've seen Sashi Urik's recent talk, Clarity, I really liked it. And one of the things he said was that separation of concerns is like the foundation for everything else that is good about code, right? Everything about clarity and communication, it all starts with that. So the other way to phrase this, the object-oriented way, is to call it reducing coupling and increasing cohesion. That makes it sound very professional. The second thing we're going to be looking for in these refactorings, we're going to try to make things more explicit to the extent that there is implicit global state that our tests might need to manipulate, or that the architecture as a whole might be manipulating. We're going to try to reduce that. This is going to make it easier on yourself when you come back to the code base in 6 months, and it's going to make it easier on your team as they're trying to figure out what's going on, right? So yeah, to the extent that we can reduce that global state, that's a good thing. And finally, we're going to look at some cases where GenServer cast kind of bites us, and the problems that causes. So those are the three things to keep an eye out for. If you'd like, there is a link at the bottom of the slide. You can go to there and follow along in your own IDE or whatever, or you can just follow along with me. So the code base we're working on is like this micro version of the code base that I work on every day. It's all about this virtual power plant, and a virtual power plant is an abstraction over some number of grid connected things, in this case batteries, that a power company can dispatch to meet a need. And in this case, batteries are a really good fit for what we're trying to do, because if you think about like a Tesla Powerwall that can power a whole home, or maybe a commercial or industrial battery that could power a whole factory. These things are capable of dumping a bunch of power onto the grid when maybe your central power station can't keep up with the demand, or if there's too much production, maybe from rooftop solar or something, they're capable of absorbing that power. So in the initial version of the app we're looking at, there is one virtual power plant. It's a singleton. And if our energy company wants more than one VPP, they can spin up a new instance, because instances are cheap. And then the other side of this, of course, is this battery registry with a bunch of battery GenServers. The VPP will address batteries via a unique ID. And so anytime we call into the battery module, it's going to be looking up the correct process to dispatch to via the registry using that ID. So let's go ahead and look at what that looks like. The application is bog standard, right? Start up a battery registry, start up a VPP. The battery GenServer is pretty straightforward. You can create a battery. It takes an ID, a maximum power, and then a current power, which defaults to 0. And the two things you can do to a battery, you can update its current power, and you can ask for its current power. The only bit of like business logic here is this limit power. So if you ask for more power than the maximum, we will limit what we actually put on the battery. Battery registry is bog standard, nothing to see there. The virtual power plant. This is our second GenServer. You can see at when the system starts up, it's going to start a GenServer with the name of the module. When you add a battery, it's going to cast. That's just a battery ID. And the state of our GenServer here is just going to be a list of the battery IDs that this VPP manages. So things you can do to a VPP, you can add a battery, you can check the collection of battery IDs that it's holding. You can ask for the current power, which is the sum of all of the batteries that it has. And then you can ask it to either dump power onto the grid or absorb power off the grid. These like mutators are set up as GenServer casts. We'll revisit that later. But yeah, so reasonably straightforward. If we look at the first tests we've written for our virtual power plant, we are going to create some batteries, add them to the VPP, and then make some assertions on them, right? Check that the current power is the sum of 8 and 3. And if we actually run this, it's going to fail. And you can probably guess why it's failed. We're adding batteries twice, right? If we run it again, it might fail on a different test, right? So it's failing because we've added this battery 1 ID twice and battery 2 ID twice. So this is the problem with like singletons, right? This is why people besmirch the name of singleton. And if you know a little bit of Elixir, if you've been around the block, you might say, I know how to fix this. We'll just do a sys.replace state, and we'll look up the singleton VPP, and we will replace its state with an empty list before each test. This will technically work. You can run the tests and it'll work, but this is obviously very tightly coupled to the implementation of the VPP. If we change its state, obviously this is going to start failing, and God help your poor junior devs who look at this and are like, what's going on, right? So what can we do to improve this situation? If we open up version 1.5, we can, instead of addressing the server by the name of the module, we can make this call into server name. Server name will read some environment state and pull out a name, and it'll default to just the module. So in our production system, if we haven't configured this environment variable, we just get the module name. And then, of course, in the implementations here, we can just call into server name. This will work. And in our setup now, we can just put this environment state. But again, this is like we're trading one bit of global state for another, right? To the extent that your tests are like manipulating environment stuff, it's kind of a code smell, right? Because your coworkers or your future self are going to have to like search through the whole code base for this atom and figure out where it's being used and what it's actually doing. A much better option is to just explicitly name our VPP. So we can accept these options. We can pull out a name if one's provided, and if not, just default to module. And then in each of these functions, we can ask, which server do you want to talk to, right? And we can even provide a nice default. This is something that's kind of unique about Elixir, that you can have the first argument defaulted. So if you call add battery with one argument, you get the module. Feelings are mixed on this. I could go either way. Some of my coworkers feel really strongly that like it's not that many characters just to type, virtual power plant when you want to make that call. But what this lets us do is, in our tests, we can say virtual power plant.startLink and pass it an explicit name. And so now each of these is setting up a new instance of our GenServer, and all is right in the world. So where we previously had one GenServer for the whole app, we can now have optionally multiple. And if we run these, I've added a few new tests to this version 2. If we run it, we're going to see it's going to fail, and it's going to fail in this test of checking that when we try to add power or absorb power from the grid, that we're limiting to the battery's max power. And the reason it's failing is that this absorb call, if we jump to the definition of it, absorb is a cast, and in the implementation of absorb, it's calling into each of those batteries to update current power. Update power itself is another cast. And so we have like these 2 layers of asynchrony. If we were to run it again, there are like 4 different values that you can get. And if you get lucky, this test will actually pass, or unlucky, depending on how you look at it. But that asynchrony is just going to make the system hard to test. And again, like a little knowledge is dangerous, right? Because you could say to yourself, I will just use sys.getState to synchronize on the state of those GenServers before checking the total power, right? And you can work out, we could spend a long time discussing why this exact series of 4 syncs is necessary in this order. But obviously the much cleaner solution, the much simpler solution is, if you don't really need that cast, like just do a GenServer call, right? And so in version 3 here, if we just change that to GenServer call, and same with the battery side, update current power is a GenServer call, then that test works the simple way, right? Like it works in the way that you would, that we did intuitively write this test the first time, right? The sum of the batteries, you just iterate over it and you don't worry about syncing state, right? So that is going to be much more maintainable for yourself and your coworkers. So let's go back to that architecture diagram. As you look at this, you kind of have to ask yourself whether the look up a battery by its ID is a good architectural decision, right? This is kind of the pattern that people tend to fall into. Like, I have some bit of state, I obviously need a GenServer for it. But to the extent that we are not really worried about isolating failures, we're not. There aren't multiple clients for a battery that that might be calling into it. It's all this one VPP. We might ask ourselves whether we need those GenServers at all, right? We could massively simplify the architecture by making that just plain data. And so let's open up version 3.5 here. What if we remove the battery module entirely and we make adding a battery just take that data that that set up the battery previously, ID, max power, current power. This make battery function can return a struct with those fields, and then we can just put all the business logic there inline. You could argue this is better for cohesion, pulling that stuff out, but there's always that balance, right, between keeping related logic together and separating things that are conceptually distinct. So this is a non-example. What can we do instead? My suggestion is that if you don't have a good reason for having a GenServer, just use a struct, right? ID, max power, current power, and then this logic, we have isolated that power limiting stuff into this battery struct, And accessing things like the current power, you no longer even need a function, right? It's just on the struct, and you can know in advance that it's going to be on the struct, right? It's not a formless map that may or may not have the keys you're looking for. The VPP can now, instead of taking a battery ID, takes a battery struct. And to my mind, this is honestly pretty close to like the platonic ideal of this system, right? So we have this stateful uh, bit of state that changes over time, the virtual power plant and its collection of batteries. But the batteries themselves are just plain data. Um, Again, this gets us back the separating out those battery concerns, but also kind of clarifying our thinking around the VPP. So the next bit that I'm going to suggest is perhaps the most controversial bit of this. When I'm looking at this, it seems like the virtual power plant is kind of smushing together two distinct concerns. The first is the business logic around like how do we handle calculating the total power for a VPP? How do we handle updating the power? We're combining that with the overall like state management over time, right? A GenServer is a tool for managing state changes over time, but having those combined, um, I feel like it could be cleaner. So let's look at what that might look like. Um, if we instead went to a virtual power plant that was just a struct, right now it only has one field, batteries, but as structs have a tendency to grow fields over time. Um, we can, so we're operating on battery structs, but then because our state is just a struct, the implementation here, it just goes straight in line, right? Contrast that with looking at version 4, where if you want to know the implementation of add battery, you have to go search on this atom. And again, like God help you if that happens to be a very common atom used for other things. Um, in this case, like the implementation of add battery is separate from the function head. And in this case, it's just right there. I like this a lot, and what you can do is, as long as you get the wire up correct of the GenServer that wraps that struct, um, you can do all of your testing on the plain stateless struct, and then testing the stateful part of it, the state management over time, the GenServer, becomes just a matter of ensuring that you've wired up to those struct module functions correctly. So the test for our virtual power plant looks like creating a struct, adding batteries to it, and we end up with the struct that we can just make assertions against, right? Um, this is really nice for testing. Um, and then our server looks like more of a smoke test than testing every edge case and that sort of thing. Because once you've got the edge cases handled in your struct module, uh, again, assuming you get the wire up of your GenServer correct, you can't possibly screw it up. So the one thing I don't like about this is that we still have so much boilerplate in our GenServer module, right? We still got all these calls. You still have to go search around and, okay, so add batteries implemented here. That's just a call to that function and so on. So this is what we were working with. A server contains a struct which aggregates batteries. There's a refactor we can do here. I have used this. It's kind of the world's dumbest method for wrapping an implementation struct. This apply call function takes a function from your struct module. It takes the struct itself, and then it takes whatever additional arguments you might pass. So in the case of our virtual power plant, if we were wrapping add body, we'd pass virtual power plant dot add battery as the function. The state would get passed, and then we would have one additional argument of this battery. So in the server wire up, we say this is what we pass to GenServer call. And then we have one handle call implementation for all of these. Again, this gets rid of some of the boilerplate, but I'd really like to reduce that even further, right? It would be really nice if there were a macro that we could use to say, this GenServer is going to export, a stateful wrapper around all of these struct functions from the module that it's wrapping, and do that in the obvious way, right? I don't have either the macro wizardry or the time to have done that myself, but if somebody wants to collaborate on that, I'd certainly be interested. Yeah, so as you're looking at this, you might wonder, why not just use an agent, right? With an agent, you can have this business logic inline, and you can get rid of this boilerplate. The problem that I run into is that it seems like every GenServer I write has some limitation that prevents me from using agent, right? Maybe it needs to handle timer messages. What that might look like is, suppose in our system we have these battery structs that correspond to physical batteries in the world. Well, when we ask to set the power of that battery, it might not actually get that power, right? Maybe the battery is offline. Maybe the owner of the battery has overridden our request. And so we need to update. We need to make some kind of call to the internet attached device at some regular interval to check and see that what we've asked for is actually what we've got. And if not, maybe we adjust things, right? This is this happens in all over our code base, right? Process.send after, we've got some timeout, and then we want to send ourselves this message, fetch remote state. Because this is so common, this prevents us from using agents in our code base at least. And the question becomes what do you do with the stateful management part of this this state, right? When you set up your VPP server, we want to take these remote update, this timeout duration and a batch size, like how many batteries do we update at once? If you've got 10,000 batteries, you don't want to send 10,000 requests every 10 seconds or whatever. So we've got these parameters that tell us how to manage the state, right? And the pattern that I've used is in our init to make our state a tuple, and one is the state itself, and the other is information about how we manage that state. This lets us unwrap those separately and kind of pull out the state management part when we need it. The alternative, of course, is to stash all that information in your VPP struct itself. But again, the idea of separation of concerns, the batch size at which you call into the VPP's update batteries, that's not really part of the VPP struct itself, right? It's not core to it. It's kind of configuring how you use it. Therefore, I do like having it pulled out separately. With that, one last architecture diagram. Our VPP server now has the VPP struct itself, and then this separate stateful config. Again, I'd be interested to hear how other people have done this. This is kind of what has worked for us, but I'm sure there are other ideas that people have. So that's what I got. By all means, hit me up on Twitter with questions, comments, criticism. And if you want to come work on a team that values thinking about this stuff and thinking about testing and architecture, we are always hiring. And I think we have a couple minutes for questions.
Thank you so much, Tyler. It was a great talk. Thank you for being here at ElixirConf. We appreciate the effort that you all speakers do. We are waiting in case we have questions. I think we are catching up with the lag
Cool, cool.
as we speak. So yeah, anyone have any question for Tyler? I think we just catch up. Cool. So everyone is super happy with you. Thank you again for this talk, and let him know if you have questions. Okay, we have a question.
Cool.
I will stop sharing your screen, and so you can see a question that we are having here.
Perfect.
It's displayed, is from Brooklyn.
Yeah, so replace state on async tests. Because those messages get serialized in the actual process, yeah, you'd end up stomping on other, like if you had two tests running concurrently and you were doing the replace state, yeah, you'd stomp on the other tests. Those first tests were intentionally not async because that wouldn't work. I don't know about you, but in our code base, we certainly have a number of tests that are not capable of running async because they are so stateful like that.
Cool, thank you so much. We also have another question. Actually, it's from Brooklyn. I think it's a follow-up.
Cool. A new server process instant for each test. Yeah, to some extent, you could make the argument that we should test everything, exactly as we're using it in production, right? In my opinion, if you are depending on that, like it's kind of a code smell, right? I think there is some value in having smoke tests where you do, where you're not just testing a single piece of functionality, adding a battery or checking the sum of the power and stuff. But maybe you're doing a bunch of manipulations over time and checking that. We've certainly caught bugs that way, right? Bugs that we didn't see in the isolated unit test. When you do a dozen things to a VPP, suddenly you see issues, right? So there's some value to that, but I think for it's like the testing pyramid idea, right? Like most of your tests should be unit tests that test some very small bit of functionality, and then you have a few bigger tests that whether you call it a singleton or a long-lived instance and that sort of thing. That's how we've handled it, right? So maybe we have like 10 unit tests to one like bigger smoke test, integration test.
Thank you so much. We have another one.
How do I like IntelliJ for Elixir? I have been a JetBrains user since college, long time, and so I'm very much wedded to their IDEs. The Elixir support is really, really good for being a community plugin, but it would not trick you into thinking that it is first party, unfortunately. I use it and I still like it better than like VS Code, but I do wish IntelliJ would invest in a first party in Elixir ID.
Oh, the code editor war. This is
exactly.
always a good one. Okay, we have another one from Chris.
Testing handle info. Yeah, in the repo that you can check out, that version 7, we do have tests of our timer there, and we specifically create an instance and say give it a timeout to make those calls of like 10 milliseconds, right? And so we create it with a 10 millisecond timeout, sleep 10 milliseconds, and then check that it's done stuff, right? Testing testing that the logic is wired up correctly, I think is valuable. But again, when the server component, the GenServer component, is like a thin wrapper around the struct, where we would spend the bulk of our testing effort is on testing the function that gets called by handle info is correct, right? So we would have maybe a half dozen tests to test all the edge cases of that update function, and then maybe one test on the GenServer to make sure that it is calling into that struct module correctly.
Cool. Thank you. We have another from Mike.
Yeah. So there are a lot of different ways you could handle it. If you look at the implementation in the repo, the batching happens by pulling off like the front, call it 10 batteries. Again, if you've got like 1,000 batteries, we pull off the front 10, update those, and then stick those to the back of the list, so that we're gradually moving through the list. We in our production system, it looks quite a bit different from this. You could have a strategy where if there was an error, you put it in a separate queue for retries, and maybe do some exponential back off there. Again, that bit about there are always new fields that you're going to add to your struct. Yeah, I would say we don't have a great answer for this. We're still kind of experimenting with how to do that.
Thank you so much. And we have one last one that I think everyone is thinking about. This
What
one.
webcam? So I bought the ridiculously overpriced LG 5K display that like only works with Macs, and it has a nice built-in webcam.
Perfect. Thank you so much. They were asking for the repo, but it's been answered on the chat. So
Cool.
Tyler, thank you so much for this talk. It was super interesting and everyone loved it. So thank you for being here at ElixirConf.
Cool. Thank you all for your time.
See you.